Hello everyone, this is V. Manikyala Rao, working as assistant professor in the department of CSE and ML in BURIT in Asapur. So now today we have to discuss about grid based methods and outlier analysis. And grid based methods, I will show you one by one what is grid based method. So we have to show in the form of grid structure. So just like the points in the form of cells. So all the points in the form of cells we need to take, and within that particular points is to be grid. This is called it as grid method, grid cell. Within that particular row we are defining. So it is used to show the multi-resolution grid data structure like this, more than one resolutions. So it shows the finite number of points in the grid structure. So it contains n number of points is to be shown in the given graph. So it is used to find out it is not contains the data points with the value space surrounding the data points. So now I will show you what is happening in the grid based methods. So these are the main steps. First we have to create the grid structure. That means first we have to create the structure like this, and after that note down the points of the densities, and based on that we need to frame the graph and identify the cluster points inside this, and finally we have to find out the neighbor cells within the given cells. We have to find out the neighbor cells in this. So now I will show you with example, you will understand. So coming to the first grid method, sting. Sting means statistical information grid approach. So in this what we have to do means, we will show all the things in the rectangular format. We are dividing that one into rectangular format, and then we have to show with the different levels of resolution. These are the levels: ith layer, level, I-1 layer. So ith, I-1, I-2 and so on, n number of layers are to be there, dividing into cells. And we have to show the attributes like what is the minimum value, and what is the maximum value. Those all the values we need to find out in the given structure. I will show you with example, you will understand. So let us assume that we are taken 2D space 4x4 in. So that means it is a 4x4 matrix grid. So in the 4x4 grid, how many layers are there means we are having 3 layers. Top layer contains one big cell that contains 4x4 area. Second, next layer contains 2x2, that is the middle layer, sub layer, and the bottom layer contains 16 cells and each contains 1x1 unit. Based on these things we need to frame the given structure. So first, top layer 1 contains the 4x4 area structure. Then we need to calculate the confidence interval. I will show you how to calculate the confidence interval. So first we have to calculate the density n by area, number of points in the cell. Then we need to calculate the confidence interval. Based on that we need to find out that is belongs to our particular relevant variable or not. I will show you with the example, you will understand. Next, the bottom layer will go to next step. Then we have to reach up to, it will make the cluster grid. It is reached to the particular cluster and refine the clustering, finally return the particular value. We will show you with example. So first we have taken the data points n is 40 and threshold value 3 and the particular per unit area. So layer 1 what we have to do, n by area. So n value 40 and divided by area value, they are given 16 in the example. So 2.5, so that is less than 3. So p value estimated 40 by 41, so but the density value is low. Now we have to do the same process. The confidence we need to find out. So they are given the layer 2 contains 4 cells, that is 2 by 2 means the cell A contains 10, cell B contains 8 and cell C contains 12 and cell D contains 10. So 10 plus 12, 22, 30, 40. So that cells we need to take. Then we need to show that is density of each one. So 10 divided by total 4 cells, 2.5. So density between B, 2, C and D, 2.5. So like that we are calculating. Then the estimated value we are getting for this one is 0.3. After calculating that layer 2, now we will going into the layer 3. So now is the standard error we are calculating. Based on that we are getting that value 0.0725. This SE means standard error. Based on this we need to identify that value is relevant to our value or not. So after calculating, so P plus Z into SE. So P value is 0.3 based on the previous. So Z value is 1.96 based on the 95% confidence interval. 0.725 is from here. And finally we got our values 0.15 and 0.44. So now our threshold value contains 3 points and cell area 4 and our ratio value is 0.75. So 0.15 is less than 0.75. So that means our value is not relevant to our existing values. In case they are given this value some 0.14 greater than 0.0. So this means those all the values are relevant. Just like for example, this is a 2.14 and this is 0.10 means this value is a relevant value from the given example. Like this we have to show the sting method. Now the layer 3. So we have to calculate up to layer 1 and layer 2. Now we are calculating for layer 3. So layer 3 contains, they are given 4 subcells and each are having 1 by 1. So that's why we are taken 1, 2 and 4, 5. So distances between the clusters, that values we are written here. So these C1 and C2 is greater than threshold value. That's why that is the relevant value. Already given. Less than means not relevant, greater than means relevant value. So finally our values are C1 and C2 belongs to our final clustering value. After refining that method, C1 and C2 belongs to our final method. So C1 and C2 contains the values are 5 and 4. So 5 and 4 is the final relevant value for this string method. Next one, another method in this click method. So click means clustering in cluster. So it is used to find out the given clusters in the high dimensional spaces and by partitioning them into intervals, whatever the ranges are there, and that ranges contains grid cells merging the dense into the clusters. That means we have to merge that one. These are the density points whatever we are taken. After identifying the points, we need to merge the given cluster points like this. So we have to match whether the given points are matched with the particular values. Now I will show you with example, you will understand what happened. So first we have to divide that one into equal with. For example, we are having 20 values means we have to divide that into 10 into 2. So each set is having 2 values, 2, 4 like this. Only 2 values pair we need to take. Equal width we need to divide that one. Then we need to calculate for each dimension L cells equal to PA means the range intervals, how many range intervals it should be there for this. Next, we need to count the number with the density value Ni by volume J. Ni means number of data points, volume J means the particular volume value particular between the density points. So next we need to calculate volume. So volume means the width value for the given interval. Then based on this, we need to identify the density is greater than value means we need to connect the cells to form the clusters and finally frame into our connected dense cells into our set. So now I will show you with example, you will understand. So see here, this is the example for this P1, P2 and so on, n number of points are there. First step, we need to divide that one into some ranges. So that's why I taken, it contains 22, 25, 23, 41 and 38. I taken the example 0, 20, 20, 40 and 40, 60. Salary also same thing, so that's why I taken 0, 20, 20, 40 and 40, 60 based on these salaries. And then next interval. So 20, 40, 20, 0 to 20, 40, 20k. So these two things contains how many points? So P1, P2, P5. So 22, 40 and 22, 40k. So those all are P1, P2 and then P4, P5. So how many points are this? Total 3 points are like this. Next 40, 60, 40k to 60k. 40 to 60 contains only P4, 40 to 60k contains P3 and P4. So P3 and P4 is to be there. Then others none. So it does not have any points, is to be matched with the examples. Now next we need to calculate the density. So Ni divided by volume. So 20 into 20 they are given, that is 4400k. So that value we are written here. And finally we are getting the density value this one and the cell value this one. So based on that values, now I will show you one by one. So we are calculating this value is belongs to dense and this value is less than, that's why that is not belongs to dense. And these points whatever we are to be given, these all are called as dense points. This is not dense point about the given example. So that is about the another type of technique in the given example. Other areas all are empty. Next concept, outlier analysis. And what is outlier analysis means? The points we are to be taken that is out of the boundary or out of the range. So see this example, we are taken all these points are near to the line, but this value is outlier, out of the boundary. So this type of values is called as outlier analysis. Now we are having 3 types of outliers are there. Coming to first one, global outliers. Global outlier means that is completely different. Those all are individual things. Just like, for example, if we are taking 10 lakhs transaction, out of that data set, out of 10 lakhs transaction means those all the values near to that. So for example, we are taking the data set 200 rupees and 3000 rupees means those are out of values. Why? Because our transactions are having 10 lakh transactions, but we are showing lesser value. These odd type of things are called it as outliers, global outliers. Individual points is to be there. Next, contextual outlier means that is to be shown in one context, but that will be different in another context. I will show you. For example, I taken 25 degrees centigrade in normal in Bangalore, but during winter, but unusual in Delhi. In normal unusual time, so in Delhi 25 degrees centigrade will be there. So normal in one context and that will be changed in another context. That is called it as context outliers. So examples, we have to take weather monitoring or sensor data, sales, we have to use the contextual outliers. The next one in this, collective outliers. So collective outliers means collection of values normally we have to do individually for the unusual data together. So see here, group of failed logins in 2 minutes. That means a number of transactions, a number of logins will be failed at the same time for this. That is called as collective outlier. The boundary of region, that means they are given some of the range. For example, at this time only 10 members can log in into our particular Wi-Fi network, means only they will allow 10 networks only. After that, when they don't want to allow, they will show not connected. That is called it as collective outlier. These are the things about outlier analysis for this out of the boundary values in the given example. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.